hands back up. Just do a quick, say something again now.
Fish.
No, not you, Dave.
Oh, sorry.
I think that's a little bit better. Yeah, just be loud and clear and slow, and it'll fade away. Right. Anyway, and 5, 4, 3, 2, 1. Oh, what were we talking about again? So we've just had a technical glitch. I've had to edit out there. Hello, everybody, and welcome to another E5 podcast. I am one of your many hosts today. My name is Paul Meenan. Today's an extra special one because I have a number of co-hosts and a new one. So let's introduce yourself first.
Hello, I'm JW.
I still have no idea who the hell you are, but okay, fine. And my other co-host.
Well, you know who I am. I'm always here.
You're like my brother from up north.
Yeah.
And I want to introduce our new co-host today. And don't hate her. She's from a manufacturer. Introduce yourself, please.
Hi, I'm Kirsty Johnson from Surge Protection Devices.
Surge Protection Devices. So you must do things with arc fault detection, maybe?
I get asked that an awful lot, but no,
you don't. Okay.
Surge protection.
So everybody's shocked. We have a manufacturer and you are the technical director, if I'm not mistaken, for the manufacturer. So she knows her onions. And just to be clear to everyone listening, this podcast is not sponsored by anybody at all in any way, shape or form. And I do not have contactless payment. And Kirsty, can you please confirm you're not transferring cash as we speak?
Definitely not.
Absolutely. We're not worth a penny. That's what she's saying. God love her. Right. Today we're going to talk about, I think it's fair to say, over the last year and a half, we've been on a bit of a journey as a gang, and we've kind of really delved heavily into AFDDs and other bits of the technology. But the kind of one that nobody's really spoken about is surge protection devices. Now, there is a bloke on YouTube, John Ward. He's recently done some great explanatory videos, so please check them out. And there'll be a link to them at the end of this if you're watching on YouTube. And Dave, we've been on a learning journey, and also Kirsty, we've done at the recent Alex a bit of a panel talk about SPDs. But do you want to start it off and just tell us what an SPD is?
So a surge device is essentially an outlet for your board to get rid of the voltage. So previously, all we've talked about is dealing with your current on your board. That's why you've got your MCBs, your RCDs, your RCBOs. You're purely dealing with current. So we're now starting to look at the other side of that and looking at the damage that occurs with any over voltage. So that's where the surge device comes in.
And weirdly enough, if you look at even on, I think it was on your Facebook group today, Dave, there was a great thread on the Sparking Ninja Facebook group.
I'm glad you remembered that. I said to you last night I said, oh, that'd be a good thing. I completely forgot about that, man. Yeah.
So there was a thread where somebody asked the really intelligent question of, do we actually need these? Is there relevance? And then a whole host of people went, yeah, here's a photo, here's a photo, here's a photo, which is where them photos came from, Kirsty. And it's absolutely amazing how many people are experiencing them. And I'm experiencing them on my railways. I think John Ward's video number 3 was the combined type 1, 2 and 3, which had blown up on one of my stations. It's a genuine thing. It is a genuine thing. I just don't think we realise.
That's it. I mean, most people, especially with surge problems, rather than the big lightning where it actually blows things up, where you'll see the physical damage, most people don't realise surge problems exist because it just means their programs won't last longer, their equipment will die quicker. It's just slowly degrading these products and causing problems nobody really associates with electrical damage.
What is surge protection? So it's a genuine thing. It was Dave's Facebook group had a great series of examples of HV cables hitting LV, pole mounted, where the board, it got into the main switch and just blew the side of the main switch out.
Yeah,
which is really lucky.
I read through there, and there was one guy in particular who had an example that I experienced when I worked in social housing. Probably 10 years or so ago, there was a gentleman who lived in a bungalow. There were 2 bungalows side by side, and they were basically surrounded by a load of terraced houses. And so for this one guy to get his free TV, he had this 20-foot aerial on top of his bungalow, like this swinging thing. And then one day, it got struck by lightning. It was in the street next to me. So I was the call-out sparks, and I went in. And when I got in, the room was still slightly smoky with brick dust. And what happened is the wall had blown into the living room. The coax had all been destroyed. all the TV had been destroyed. Some of the equipment had been destroyed. The kettle still worked. The toaster still worked. The 3036 semi-enclosure fuses were like, what was that? Nothing at all. Nothing operated. But that's 10 years ago. A lot of the equipment was resistive heating. A lot of it wasn't electronic. But I still had seen it back then. But there's a lot of examples that are more modern, more today. And I remember Jono actually mentioning on Twitter that a lot of people still don't understand that this isn't just lightning. We have a habit of dramatizing. I see the same thing in arc flash. When people go, oh, arc flash, we look at the huge arc flash, magnificent of a high voltage arc flash, when we don't consider the low end spectrum of a low voltage arc flash. And it's the same with surges from my perspective. We always see the magnificent lightning strike and we go, oh, it's lightning. When really, especially with today's modern technology, it's vulnerable to many lower transients.
I think we were very clear though. If you're talking about lighting, you're talking about a standard, correct me if I'm wrong, BSEN 62305. Which deals with lightning protection system and the associated surge devices with it. What we're trying to help understand and develop is our application of the requirements for surge protection within low voltage installations within 7671, which is a slightly different beast, almost like a distant cousin of it. And I think it's just confused people because people just go, oh yeah, standard lightning protection bloke, mate. Really? Is it? John, what's your thoughts on the whole surge protection?
Well, the thing is obviously you can get the stuff coming in from outside, but of course you've also got the stuff that's within the installation. And I've actually seen not that long ago where this was a commercial one, and it had LED lighting, those sort of recessed panel things you get in the ceiling, and one of them had failed. And I took it out, and when you actually took the back off and you saw the driver, there was a big black mark where some component obviously just busted and shorted out, and it had tripped off the circuit breaker. So that was sort of fairly normal. But what wasn't normal is that the light next to it on the same circuit also didn't work, but there was nothing visible on that one to say that that was sort of blown up as well. So it's highly likely that the fault that the first one had caused, and obviously there was that big pulse of current went through when it shorted out, presuming that had damaged the one next to it as well. So that was entirely within the installation. So it's not just about lightning coming in and or things coming in from outside. It's of course stuff and faults that occur within your installation that can obviously damage things as well. So one light fails and you end up having to replace two just for the fact that it was in close proximity to that first one.
I think Kirsty, tell me if I'm wrong here. It was in the appendices for external influences. It used to be the AQ code. It was known as, if I remember rightly, but nobody actually knew it because not many people actually look at the requirements for external influences when they're designing, because it's bit of twin and earth, bit of conduit, job done. Same as same old. A lot of electricians live by some very simple, basic installation rules. But then you wonder, you look at a job and you go, wow, look how corroded that is. I mean, you've only got to look at our Instagram account. Some of the rotten installations there that are 5-6 years old and they look 50 years old. John, you were saying about switching surges. I think on our group, I found probably about 12 months ago now, some ballasts in some lights had swollen up to the point where they pretty much popped and all the gunk inside had oozed out and had basically started to smoke. And we found a whole row of lights, and as we went down, the damage was less and less. But you could actually track the damage and the heat that had been generated and made the cables brittle and all sorts. And that we literally put down to some sort of surge within the installation, because the surge protection device wasn't working anyway, so it definitely did something. So the 18th edition changed the requirements quite a bit. I think that's fairly evident. I think it removed this AQ code, and it just threw everything into confusion. And I think it's fair to say, Kirsty, when we have done the elect shows, it's been well attended because people want to understand it, or people want to tell me if I'm wrong here. I think people want to understand the framework for why we do it, the benefits, the negatives, the formulas, everything. And I think in our talk we actually mentioned some statistics on why we would use it, and the statistics was a sample comparative between 2008 and 2018, where in 2008 17% of people had smartphones, 2018 78%. It's now 2020, that's probably up in the near 90. DVD players are used less, tablets are used more. DAB radios, 27%. Now there's 64. That's going up all the time. Smart TVs in 2008 didn't even exist, but then now at least 42% of all TVs are smart TVs. That's only going to go up. So our usage of technology, you know, USB socket outlets barely existed back then. Too expensive. Now they're in every single house.
Exactly. I mean, surges aren't new. This is the thing with the regulation changes. A lot of people are assuming there's something gone wrong with the electrical supply. Surges are not new. They've always been there. It's just we're plugging in such sensitive equipment now that they can't cope with the fluctuation in voltage.
Are you saying that we now have snowflake installations?
We do.
Is that a thing? Is that a new term for the electrical industry? Where did I get that from? Snowflake electrical installations. Be gentle with my DVD player. It doesn't cope well with transients. There, it'll be okay. Don't worry. Yeah, these surge protection devices, I think, for me, it's just a natural. I mean, Dave talks about it best. You've got your basic protection, you've got your fault protection, and then you've got your additional protections. I stick this in the additional protections, but a far more cost-effective one than arc fault is, given the expense of arc fault, and a common sense one as well, because I'd be devastated if my iPhone blew up because it cost me like 1,200 quid.
Yeah, I mean, the fundamental principles are about ensuring the safety of persons, livestock, and property. This is a risk to property, which is therefore a risk to everything else.
And maybe the JPEL committee can actually say protection in when they revise, if they ever revise Chapter 13, they can actually say persons, property, livestock. They can actually say and technological connected loads, or something of that. I don't sit on JPEL. You sit on JPEL, Kirsty, don't you?
I do.
Oh, well, maybe you can have a word with the relevant committee persons.
I'll put it on things I need to have a word with them about, shall I?
Yes, please take a list if you don't mind. Yes, and give them our love. Give them our love. Not that we've made comment on the JPEL system before. Yeah, so there's lots of technology requiring. What?
Big fans.
Big fan, huge fan. Yeah. I'm going to ask for autographs soon. Do you know what? I'm very tempted to bring my regs books to next Alex and say, can you sign it, please, next to your name, just so I can collect it. No, I would never do that. So a surge is, for those who are thinking, what is a surge, still don't get it. If you look at that weird squiggly line known as a sine wave, if you have a big spike on it, that's known as a surge. They happen very, very quickly, or they can happen for a duration, depending on how bad your luck is. Really, there are different types of devices to protect. Now, I'm handing this over to John because who better to tell us?
Thank you. Go for it.
Go for it, John. We rehearse these, as you can tell.
Yeah. We're doing the types, are we?
Yeah, we are. Sorry.
Yeah.
Sorry.
Device
would
types,
you like to tell us the types while John is composing himself?
Type 3, type 2, type 1. Go for it.
Go for it. So where would I let's lead the question in then. Where would I apply a type 1? What is a type 1 and where would I apply it?
Okay, well, your type 1 is for a building that's either got lightning protection or it's got overhead lines coming in. So in other words, it's going to be more susceptible if a direct lightning strike hits the building.
Yep.
Anything else, you're not going to need a type 1 because say it's only used on those two situations. So certainly for things like domestic properties, it's pretty unlikely you're going to be putting a type 1 in unless it stays somewhere out in the country and it's got some big overhead lines supplying it. For most of those, it's going to be a type 2, which is going to go in most of your sort of normal types of installations.
Okay, so I'll stop you there. So a type 1, we would expect to find it on a building that is fed from overhead lines, which would be obviously rural areas, countryside, farms, etc., etc. We would expect to also find it in buildings with lightning protection systems. Now I'm being told to stop. Go on.
So,
go, Kirsty.
Yeah, the thing is with the lightning protection systems, a lot of people default to, well, that's the lightning protection installer's issue. That's to do with him.
Yes.
More and more frequently now, I'm ended up on site where they've got lightning protection systems installed and have no type 1 on the main incomer. This is an issue. Yeah, it's crazy. This is an issue because what a lot of people don't realise is when you have a lightning protection system, it's cross-bonded to your MET. Which means essentially if you get a lightning strike coming down that lightning rod, it is coming straight into your property. So we need the lightning device there essentially to break that capacity.
Yeah, that's baffled me. Sorry.
I can actually accept that. I have seen buildings with lightning protection systems, and when I have had the unfortunate pleasure of being handed a report, it said there is no surge protection. We recommend it's done, but by the way, we're not doing it. We recommend you get an NIC registered contractor to do it. And you're like, hang on a minute, how can these people go around? Oh, that's it. They're arse covering. So they'll do the install of the stuff that's their bread and butter, but when it comes to going in the building, other than bolting on cables, because you don't need heavily skilled persons, they just Teflon it off and say, we recommend you get an NIC contractor. Job done. I've seen it. I saw it at TfL on buildings.
And just say it's not compliant to 62305 unless you have a surge protection device fitted. They then generally hand that to somebody who doesn't understand that, a receptionist or someone like that, who'll file it away and never looks at it again until something goes wrong.
Wow.
That I can absolutely justify and verify, because I have seen it on many buildings. When I was working at TfL, I remember getting the lightning protection reports, and I would go straight to the end for recommendations, and I'd go, whoa, hang on, what are you doing about the recommendations? And they'd go, oh, well, you need to tell us what you want to do. I'm like, well, I want a fully compliant system. Why is it not compliant? And then you look back and you go, it's the same thing every time, surge protection. Nobody's actually done anything with the surge protection, because it just, when you look at it, it says recommend get NIC contractors. Those generic words that companies use, like, you will use an ECA or NIC. I'm not digging out the NIC. It's just that generic phrases that are put into documents to discharge their duty. And yet you're right. But if I might say, BSEN 62305, when it first came out, all three parts, I was like a Rottweiler reading it, and I tell you now, I couldn't understand a damn word it was telling me. Sorry, go on, Kirsty.
4 parts, sorry.
Four. Oh, it's 4. There you go. So there was only reading 3 of them, but there you go. I was very poor. I couldn't afford all 4 parts.
Surely in the design part of those systems, it has to ensure it doesn't compromise the fixed electrical installation as well.
Well, you're not if you're not touching the wiring.
Well, yeah, but you're obviously, if you're going to create a light protection system around, it's going to have a risk, obviously, as you say,
like explaining that to a board of directors who only care about bottom line cost and everything else. They're just going to go, ooh, electricery, ooh, invisible electric. It'll never happen to me. Let's put it on the risk register.
Well, how I like to conclude it, magic.
Magic, indeed. Yeah. So type 1s then, you could assume, and Kirsty will tell me if I'm wrong, that type 1s you would find on most industrial commercial buildings that have lightning protection systems. I think for those listening, type 1 definitely, if it's an overhead line supply, if it's that commercial industrial which should have a lightning protection system. A lot of them do have the old 6651 lightning protection, which then became BSEN 62305, and they've never done that gap analysis. So I have installations where they've been installed to BS 6651. They're now assessed to 62305, and there is a gap. So I then have to now decide whether I want to close that gap, and of course I always do, because I would prefer my systems to be compliant to the current standards as they're inspected to.
It's been a while since I read these, so forgive me. Are these the ones that do these include the spheres of influence?
6651 did, if I remember rightly. That was where it pretty much came from.
Yeah.
62305, I've always said it's designed to confuse most people with common sense.
Yeah, sounds like it.
It takes geniuses like John Ward and Kirsty to actually work the magic of it.
All right, so if that's type 1, does that mean that on an installation that's the only device I would need?
No, not necessarily. A type 1 generally, speaking from my company, obviously I can't speak for other manufacturers, but a type 1 tends to be a type 1, 2 and 3. So it'd cover that board, and you've got sort of a 10-meter radius from that. So if you have any sort of further subboards in the installation, they would quite possibly need their own protection.
Yeah, okay, I get that. I have some personal experience with surge protection devices not working very long or very well. I think it's just more for the electricians, really, the type 1. I think it's fair to say that unless you're in the outer country and it's a big old house and it's fed from an overhead line, you're probably not going to experience type 1 unless you're doing commercial industrial. Does everybody agree or disagree as a generic kind of rule of thumb?
As a rule of thumb, it makes sense, yes.
Yes, it does, doesn't it? Right, okay, so type 2, Mr. Ward.
Yeah, type 2 is probably the most common thing that electricians are going to be fitting, and that's for buildings that do not have lightning protection or overhead lines, which, let's face it, in certainly domestic areas, that's going to be pretty much all of them. That's the one that goes in your consumer unit or near the origin of the installation. And you've probably seen these already from various manufacturers. They are the little modules that just go inside the consumer unit, or you can get them in the separate standalone devices that go outside of it. And that's pretty much type 2 for that one.
So, John, would you fit a type 2 in your board at home?
If I was fitting a new board at home, yes, I would. I fitted a type 2 just the other day, actually. That other one from the different manufacturer.
The other manufacturer we won't be mentioning that has it built into the main switch.
Yes, that's the one. So.
Okay. Yeah, John. Yeah, so, bless. Oh, it's all getting emotional behind the scenes here. Right, so we can talk about other manufacturers. We're just not allowed to swear and curse, and we've got to be professional. So yeah, you fitted one that was combined on a main switch. I actually have one that's a different manufacturer that has a metal enclosed main switch with surge protection device as well. I'm yet to fit it just because I haven't got time. I'm a bit lazy, and I'll do it in my own time. But so type 2 is for your more domestic installer, and generally it's to try and protect within. Is it, Kirsty, 10 meters as well with the type 2?
Generally, yeah, that's the general rule with surge protection. But when we're talking about a domestic circumstance, we don't so much need to worry about that distance, purely for the fact you have no other distribution boards. So you can't really protect any further unless you've got fused spurs or something like that. You want to protect specifically if you've got a sensitive electronic boiler, for instance, you'd want to put something there. In general, for a domestic, we say put one on your main incomer, and that justifies the installation.
So that's just considering the fact that in domestics there's not likely to be any further sub-distribution where there'll be a key point to install one, because it's not likely to be like that. It's not recommended, or it's just okay.
Interesting. So if you're working on a house on the King's Road in London and you've got an installation where it's 3-phase and you've got about 15 boards, then you probably would put one in each, because the distance between the boards would be quite big. These huge mansions, you need to consider a proper method of protection or enhanced protection for that distribution system. I would, if I was doing a domestic home, because in London you get some massive mansions that are 3-phase supplies, not just single phase. You would I put a type 1 on the mains? I probably would, actually, to be honest with you, because for me I just see it as a common sense method of protection for all of the electronics in the building. And Kirsty's going to tell me off now. Did I say type 1?
I am going to tell you.
You said type 1.
Yeah. Yeah, no, not a type 1, definitely a type 2, definitely.
Type 2. Did I say type 1?
You said type 1.
I'm nervous, okay? I don't know what I'm doing. I'm winging this.
I have that effect on men, don't worry.
Sorry, no. Type 2. So, did I really say? Oh, I'm going to listen back to this. Okay, yeah, sorry. Type 2.
Type 2.
Domestic installation. So type 3, you may want to consider putting at a electronic sensitive boiler, something that is delicate. We do have more electronic boilers going in, don't we, chaps? And these electronic boilers in themselves are causing chaos, because some of them are reporting to want special RCDs, which require a type B protection, which would pretty much bankrupt people, because they're not going to be cheap. Some of them require type A's, and the poor plumbers that are going around fitting them have no idea. But it's okay, because some of them are getting, what is it, the integrated fuse spurs with they've now gone type A protection, so that's fine and dandy, apparently, according to manufacturers. So there's a big problem there stirring on the horizon. Okay, type 3, Kirsty, your thoughts on the application of type 3. Where else would I apply a type 3 surge protection device?
So generally a type 3 you'd use to protect the specific thing you want to protect at the end of the line. So I always think of a type 3 in terms of a school. So you've done the main incomer, you've done the subboards, and then, for instance, there's a fire alarm more than 10 meters away from your sub. So you'd put a specific device there to protect that. And with it being a health safety circuit, it's something you'd just consider at the end of the line.
So it's just like a continuity of service consideration.
Essentially, yeah. I mean, the school I'm thinking of in my mind now, it's a site survey I did myself. And what happened was the distribution board, the cable out of that ran by the front of a lift shaft before it got to fire alarms. So the lift was inducing voltage onto the cable, which kept blowing the fire alarm system.
Oh,
So we put something at the fire alarm to protect that specifically.
interesting.
Well, lists we do know are common sources of electromagnetic interference, electromagnetic disturbances, and bastards basically to the circuits.
So you can also use type 3 for PLC, security alarms, CCTV cameras, satellite dishes, interestingly, telephone sockets. I think we discussed that, Alex, didn't we? There's another potential, you know, a lot of sparks are saying, oh, I don't have any overhead lines in the property, so I'm not going to bother. Well, you do, you have your BT telephone line. Well, I don't, I cut mine off my house. But did I say that out loud? Yeah, sorry, I did. Yeah, no, I used to have a BT line on my house. It's gone. It got in the way of a skip. It had to go. But yeah, so don't worry. It's gone. It's gone professionally. The BT engineers came along and they made it. You know, disconnected it. But so yeah, a telephone line is a key indicator where you could get a surge protection. I'm trying to dig myself out of a hole here, Dave. Data systems. You know, places where you're storing critical data or information. Single sockets, depending on what's connected into it, or even LED lights could be used as surge protection.
Exactly.
Type 3.
So it's sort of anything at the end of the line that you want to protect. That's very critical.
So that's specific equipment, isn't it? Really?
Yeah.
So I mean, I mean, clearly we've got an issue where we've got a huge increase in the number of the types of equipment, the quantity of equipment that is much more subject to any potential voltage disturbances. How do we educate electricians to actually be able to identify that, and what the common causes of these voltage disturbances could be? Because it's not obviously, you know, we want to not think of lightning. When you think about you mentioned the lift example here. How do we get electricians to think beyond? Oh, it's not like, you know, lightning's not a problem, I won't think of surge.
Yes, I mean, in domestic circumstance, you could think of it as every time you hear your fridge compressor kick in, it's sending a voltage spike onto your system. Every time you switch your light switch on or you start your washing machine and the driver kicks in, anything like that will create a surge in the system. Obviously, the magnitude depends on the sort of voltage pull it's pulling anyway.
Yep.
But in terms of your fridge, definitely a domestic one is quite a big one.
This is where I then would throw at Paul. Do we think electricians have that understanding?
No, because it's not taught in FE establishments,
Right.
especially at the moment. We know from experience where we've been to an FE establishment and the IET were there to do some special teaching of surge protection, and it was I'm not going to lie, it was a struggle because it went into the depths of the calculation, which I know everyone listening is dreading. And I personally, I think, yes, sparks need to develop a knowledge and an understanding and appreciation that when somebody says, oh, there's an MOV, it's a metal oxide varistor, and you know how it works and the fundamental application of it, but they know in trade talk it's an SPD, it's a surge protection device. And
it's similar to the understanding we had with our previous discussions about RCs, where we need to move from understanding thermal effects to electromagnetic effects and voltage disturbance effects.
yes,
We focus so long now on thermal problems.
well, that's most
We're
of
not
the regs.
thinking about the electromagnetic problems and the voltage disturbance. A lot of electricians just don't have that ingrained understanding to clearly select SPD selection.
And this has been one of my ongoing campaigns for ages, because you know when Joe Robinson, bless him, did the video with John where they talked about thermal, magnetic and chemical effects of an electrical installation, that whole book is based around thermal. There is virtually nothing on electromagnetic, and the ideal part of external influences is the AM7 code, DC in an AC network, refer to a regulation that does not exist. There's no guidance. There's not enough because it's the invisible electricery that we can't see. And surge protection, I think, falls into this, because I've had many a debate on surge protection at work with my management where I say, I have an issue here, I believe it to be transients. Then you have to try and educate them what transient is, what surge is. And we are changing the hearts and minds of whether it's commercial industrial management or the domestic homeowner. Of years ago in a house, you had resistive or inductive loads. That was it. And we installed for that. We now have mini computers, microprocessors, power electronics, transformers, micro switching loads, super energy efficient stuff that causes bigger spikes than what we had before, and just chaos reigns supreme. But we can't see it. We definitely don't want to touch it. We can't smell it. Occasionally we can hear it from the example of a compressor kicking in on a fridge or a washing machine, and that that journey of knowledge hasn't really started, and I don't think it helps. And I think it's fair to say, as when you look at all the marketing material, you have a magazine with a big, massive lightning flash on the cover, because everyone goes, "Oh, it's lightning protection, yeah, it's steep protection, yeah, it's them blokes on the ropes there, they'll sort that one out." So the hearts and minds are never there. But from a marketing and look at me, it will always bring the eye. Look at that big flash of lightning. There's a great one I put on Twitter the other day in Southend, where lightning was going all over the place. Fantastic.
It was a great picture, but the point really is we've got to make this much more relative to everyday sparks, because it's there.
Yes.
You know, I mean, the attitude of, I don't want to say any specific voluntary bodies or anything, just kind of say, "Oh, you don't need it," especially in the domestic. "Oh, it's not needed, not needed." Bad attitude. We need to try to tell and show electricians why it should be considered, and talk to their clients and just look around and see, yes, it's needed.
But I think there's a. Sorry, John.
Yeah, on that thing about the whether it's needed or not, certainly on the domestic thing, I mean, there is that thing where instead of, if there's not anything of value in the installation, you don't need to fit it.
Yeah.
Well, pretty much whose house is that? Because everybody has TVs and everybody has expensive stuff in there, whether they like it or not. So
it's just a quick method to stop
yeah.
those lesser trained sparks thinking.
Yeah, and I say it's not about big lightning strikes hitting your house, because that's a great event. But of course, these surges things are there all the time, and say everybody's got expensive stuff in the house that's 50 times more expensive than fitting surge protection. So that sort of clause, "Oh, you don't need it if the customer doesn't want it, or there's nothing in the house that's valuable," it doesn't really wash, does it? Because it's, say, find a house that doesn't have a TV in it for a start.
Sorry, Kirsty, you want to say something?
Kirsty.
Yeah, I'd just like to say further that obviously they're the things we're considering coming from inside the house, but we've also got external influences we've got to think about that aren't to do with lightning. For instance, Storm Ciara, which I'm terrible with pronunciation. I had a customer contact me that was a customer of Electricity Northwest, so my sort of region, and they had a statement from them because they'd had damage in their property because they'd had a power outage. And the statement said that if their property should be fitted with surge protection, if they don't have that, that's down to them, not down to the electricity board.
Oh, wow.
Jeez.
Wow. One of the guys in my Facebook group said yesterday that one of the surges he experienced was where a high voltage line fell into a low voltage line.
Yep.
That's not lightning. That's obviously some kind of storm effect as well.
Mm-hmm. Yeah, and you do get that. I've seen loads of installations out, especially around outside the M25, where you've got high voltage national grid lines, and then LV poles in fields for farmers and stuff. So I can see that happening quite a lot. But just to sound like I know what I'm actually talking about, and to be a bit technical, regulation 443.4, it's entitled overvoltage control. And rather than getting into the calcs, which I know John Ward is dying to get into, I can just see it in his face. There is a regulation that says protection against surges shall be provided where the consequences caused by overvoltage could result in serious injury to or loss of human life, result in interruption of public services and or damage cultural heritage, result in interruption of commercial or industrial activity, or affect a large number of co-located individuals. Interesting. What's your thoughts on that, guys? You don't have any, do you?
I'll
don't care. I'm just an idiot. All right, yeah, I'll just switch off then for the rest of the day. Sorry.
I mean,
yeah, that selection of things there. I mean, resulting in interruption of commercial industrial activity. That's pretty much any commercial or industrial installation there straight away. Because obviously, if you've got an office or a factory or whatever else it is, it's going to be half shut down because of some problem. Well, clearly, you don't want that. So that set of only 4 things pretty much covers massive areas of things. So the only thing that's not on that list basically is your single domestic dwelling, which then comes down to that thing about the value. So this idea of, oh, you don't need it, again, it doesn't really fit, because anywhere that's like that is clearly going to be affected, and it's going to be, certainly in the commercial industrial area, a massively expensive thing if, say, half your installation is taken out.
Well, there is another section within this. There's a note, and it states surge protection may be omitted for single dwelling units. Again, those wonderful use of the word dwelling. What defines that? Where the total value of the installation and equipment therein does not justify such protection. So that's, to me, a dwelling is where somebody lives. and that basically my phone immediately tells me I should be installing one, because the value of my phone definitely justifies, if I'm doing a board change or an upgrade, having surge protection installed. However, what that does do is dangerously create a common framework of some very simple rules, which people will use to just farm out to customers without understanding the reasoning and the logic behind it. And one of the things I think that your presentations at Alex does is it tries to inspire you need to understand the reason why you're doing it, because sparks don't necessarily need to maybe do the formulas or the calcs. Oh, and just on the formulas and the calcs, the ECA have got a online surge protection calculator, which is available to everybody, including non-ECA members, and it's rather good. So you can just, it helps you go through the risk assessment process to get your calculated risk level and all that, and it's a good thing. I think it's a really good thing. So round of applause to ECA for that.
Only if you know how to put the right info in.
Oh yeah, you've got to understand what you're doing first. Yeah. But at least you know where the exit is. You've just got to make the journey to it.
You've still got to put the data in.
But small steps. Remember, everybody's on a journey of learning. There is a risk that these narratives can create basic, common frameworks of understanding which are too simple, and then people don't know why they're doing it, and then they misconstrued the additional requirements. John beautifully demonstrates in his videos about the length of runs, the connections, etc., taking the shortest possible route. So we are basically developing a journey of understanding, or CPD for electricians, that this is another protective measure for an installation. And like with MCBs, people need to understand it's thermal, magnetic, etc., how RCBOs bolt in. I see the same principles and journey of understanding that people need to go on surge protection. I think it's dangerous to an extent to create a common framework of rules, but it's okay as well, as long as they understand the reasoning behind the application of those rules. So I think this is going to be one that I think the industry needs to get right before arc fault becomes more prevalent. Because I think arc fault's going to happen and it's here to stay, but I think this is a more important safety factor given the switching loads we have in more modern technology, more stuff coming in the house. I think I just think it's. What do you think, guys? Sorry.
I'd just like to quite commonly say, you're saying that they're going to come before SPDs, and to be quite honest, in my experience, people are more bothered about protecting their equipment than they are about their lives. So I think they will be more bothered about protecting their equipment, especially in the domestic circumstance. My favourite one in that list of over voltage controls that you went through where you shall fit it is the serious injury or loss of human life. And a lot of people overlook this one. They sort of think, oh, that's hospitals, and leave that to it. They don't consider it's any life safety circuit. So any board that feeds emergency lighting, for instance, if it feeds a fire alarm, or if it feeds a sprinkler system, even when you go into social housing where you have the sockets with the emergency phones and the pull cords, everything like that is a life safety circuit.
This is where I mentioned to you earlier on about continuity of supply. If we actually bridged that to the continuity of supply requirements of BS 7671s, electricians would see it that way. With safety services, they would go, right, we need to establish continuity, we need to consider over voltage protection, and there should be a regulation in continuity of supply, part 335, 335, 34. There should be a sentence in that refers forward to 443, which then assures that there will be sufficient over voltage protection to maintain continuity of supply of any essential equipment. There you go.
Yeah, do you know what?
Take that, Jake.
If I remember, steady on. If I remember rightly, in college when we were learning about over voltage or continuity supply and all that, it was always considered it'll never happen to you. It'll never happen to you. But look at the electrics that I was installing when I was an apprentice, totally different from the stuff we're installing now. I remember commissioning UPSs, 30 kVA UPSs on London Underground, where they filled entire rooms and corridors. And now and these are just like the inverters. And now the inverters are the size of a PC hard drive, and you can hot swap them, and they're tiny. And yet everyone goes, these are brilliant. The benefits. But there's disbenefits as well. And that could do with earth leakage. That could be with higher switching surges for very short periods of time. Look at VSDs, the way they manipulate sine waves. You know, I've worked with VSDs, and VSDs are found on certain large equipment. You'd manipulate the sine wave and manipulate the current form to get slow starts or soft starts and run it as efficient as you can. But then you'd get harmonic issues. So you're having to put more filters and more gizmos to protect against. You know, if you break it into RCDs, AC type were fine. More electronics. We now realise there's DC leakage. We're now going for Type A. Some manufacturers are pushing the boat out to Type B. What did we say the other day, Dave? If it goes over 10 milliamps, you don't have an RCD protecting you.
No.
Do we need to reconsider the entire application of RCDs? Yes. Could we maybe possibly go back to some first principles and only look at reasonably practicable protection of, can we do surge protection? Well, yes, because it's Kirsty, tell me wrong, it's an inert device. It only works when it needs to. That's what it's designed to do. AFDD, yeah, I think it has its place, but maybe AFDD combined with MCB only. You look at ABB, they don't do they do an option where you don't have RCDs because potentially of connected loads. It gives you them loads. So I think the way we select and erect over the next 10, 15, 20 years is going to change, but I do see surge protection as an absolute necessary thing that we need to embrace, learn the criteria, and upskill ourselves.
To be perfectly fair, I think surge protection should be the starting point, because surge protection is outside of our control. You know, overcurrent protection, earth leakage and overcurrent protection are subject to our poor design or poor installation methods. You know, because you don't need overload protection, you have no overloads. You don't need fault current, you have no faults. But obviously, these are foreign characteristics which we don't have control over from the external of the system. So we should start with SPDs.
So
any design.
I want to go into the hardest part of this podcast. This is the bit where people have fallen asleep, and this is where John has been waiting all day for. Risk assessment, this calculated risk level, or CRL. I don't know where do you even start? Go on, Kirsty.
Kirsty wants to start.
Sorry, can I just jump in before John starts? Everyone gets hung up on this risk assessment. It's one of the biggest questions I get asked. But the risk assessment is only relevant if you haven't encountered them 4 points before. And as John said, that covers most installations. The risk assessment is only for after if you find that 1% of installs.
We found that magical little install that doesn't require those 4, and we are in that scenario. Okay.
Yeah, I mean, this calculation, which is in the regulations, it's the one with the big map of Britain with the lightning density and all that kind of thing. Yeah. So it's only going to be done if one of those, or all of those things do not apply. So it's not going to be commercial, industrial, and there's not going to be lots of individuals. It's not going to result in interruption services. It's not going to result in serious injury to loss of human life. So all of that stuff does not apply. So you've already got rid of probably 90% of installations straight away. And then, even when the calculation is needed, bearing in mind it only covers things that are external to the installation. So it's not going to cover things like switching surges coming from within. It's only for things coming from outside. So in terms of applying the calculation, it's a very, very limited number of circumstances that you're going to need to do it. It is certainly not the case you're going to have to do it on every installation, or even most of them. So if you get down to it and you've actually gone through all that stuff and it doesn't apply, and it's only going to be in this particular thing, then yeah, you can do this calculation, which is the one that's based on the length of the cables between your property and the overhead line and the transformer and all that sort of thing. And I'm not going to go through it in mega detail in this particular one.
The regulations state for all other cases. Now, I have, while you've been talking, trying to think of every other case imaginable, and based on those 4 points. And I'll tell you now, I'm struggling because I was thinking water treatment, no. Fairground, no. I'm just trying to think. Data set, no. There's just, I can't think of anything. I'll tell you what, if anybody listens to this can think of somewhere that doesn't fit within those 4 bullet points of result in serious injury or loss of life, result in interruption of public services or damage to cultural heritage, result in interruption of commercial or industrial activity, and affect a large number of co-located individuals, that could be a tower block straight away.
And it's not domestic.
And then you've got the value of a single dwelling unit.
Let's remember that commercial activity doesn't mean large commerce. Commercial activity is relative to the business. Yeah, yes. So you could be a small business, you could be a large business. It's relative to the nature of your business. So if you think it's a small business, a small commerce, that's not your decision to make. That's the client's decision to make about their commercial
And
know.
well, I have this view on my wonderful little railway where I have what I consider normal electrical supplies for electrical equipment. I then have revenue critical equipment, and then I have safety critical. My safety critical being my emergency lighting, my fire alarm systems, and my DOO camera systems for safe operation of the railway. My revenue critical is my TVMs and my ticket selling machines, and they are now being surge protected correctly.
Yeah.
John, what's your thoughts on the risk assessment, and Kirsty as well? What's your view? So actually, Kirsty, you sit on JPEL. Can I be really? Oh, I'm going to annoy people. Can this get removed? Can Amendment 2 or 1952? Can we just ditch it, or just say in case of buy another book or something, or just get rid of it because it confuses the matter. Those large volume of pages, it's quite heavy, to be honest with you.
It really does. I mean, I'd be quite happy, to be quite honest, if it was removed.
Yes, you heard it first.
Other manufacturers feel differently about it, and obviously other people on the JPAL committee feel differently about it.
Well, we'll have to get them on this podcast and grill them, and we will say, Kirsty said it's going, so back her or do one.
I'd like it to go. I'm not saying it's going.
No, that's fair enough. We would never put you in that situation, although she has just agreed on this podcast it's going. No, I'm only joking. I'll be honest with you, I've spent a few hours looking at this because I'm going to do a talk in Exeter, and I don't want to talk about it because it's quite depressing, to be perfectly frank. And the likelihood of anyone using it, if our four minds can't think of an installation where we would do this in, it's very highly unlikely it'll ever get used. So
have you actually ever seen an example of this having been performed?
Good question.
I've performed it in like mock
but so in real situations where you have to actually obtain measurements. I mean, what is the rough timescale to do this, in your opinion?
I have no idea. I mean, you've got different organizations, and like NAPIT and I see things like that, they recommend different things. So some circumstances you should really be speaking to your DNO and getting these measurements to ensure they're sort of correct. Other people are recommending that you sort of approximate because you only need the nearest kilometre.
I see that summarised a lot. To be fair with you, I mean, I have to cover this in training, and I do my best. But if I did this professionally, I'd probably just give the client an SPD at my cost to save the cost of me doing this.
It would be less of an argument, wouldn't it?
It would be cheaper.
Yeah, and the thing is that within that calculation, there's actually a bit somewhere that says that if you don't know the lengths, you can just assume that one of the figures is 1 kilometre. And if you actually put that in, basically it comes out that if you live in a rural area, you need surge protection, and if you're in an urban area, you don't. But of course, that's only assuming you're already into doing it and you've already missed out all the other stuff.
I use it mainly for the environmental factor to give the learners a good understanding of the differences or the likelihood of rural locations being more exposed if you are on your own, isolated, whilst if you're in a built-up city, if you were to look under the ground and see a huge mesh. So I use it as a good example to see how it correlates. But that's all I do with it, to be fair. So that bit helps. The environmental factor part helps.
I think it's really good for contractors to get comfortable with risk assessments, get comfortable with these sort of equations, even though they really don't want to be. I don't feel like surge protection is the right application for it, but I do think it's moving. The industry itself is moving towards contractors having to get more comfortable with those sort of calculations.
So as an end user, I can tell you now the whole system of, so me and my boss have regular debates about this, and it's a confusing one because if you look at everything around lightning protection, I'll start at the top and go into lightning protection systems. If you look at lightning protection systems years ago, the standard 6651, a lot of buildings had protection systems put into that. Then it changed to the 4-part BSEN 62305. So if anyone wants to know more, go and look at those standards, read for yourself. You'll get lost in the 4-parter because it made me want to just it just made me so depressed, and I only got through 3 parts of it. It's incredibly difficult to transpose that into any sort of Janet and John simple language. And the worst thing is it's fairly evident to me, and Kirsty, you can tell me wrong, that the parts of 62305, some of parts have been mapped into the wiring regs to ensure that there's synergy between the two, because it's fairly evident there are gaps. The guys who are doing the 62305 upgrades are not doing the electrical installations, and the Sparks have never really had to worry about it because it was always the lightning protection guys. I see this as just synergy and common sense where we're informing the installer, follow some simple rules, and do the work or do the risk assessment. But either way, you need to know more about this, because maybe other parts of the industry aren't doing such a good job. Possibly, it could be stated.
It's one of them common things of it's not my problem, it's his problem.
Yeah, and I'll agree with that.
Which happens.
And I back that to the hilt, Kirsty, because I've stood with major lightning protection companies who have literally said, not my problem, I don't do that, I can't get the guys to do it. I've been told to go and get an NIC, you go and get an NIC contractor, and we'll leave the cable for you, and they will just connect up and do this, and that's as much as we'll do, and we'll give you a certificate. And I've seen that many times. Now, some people will say, the cynics in our industry, I think there's a few, maybe 100,000 of us in the industry, that the reason this stuff goes into the wiring regulations is to feather the nests of the manufacturers as a commercial gain for manufacturers. Now, maybe 10 years ago I would have said that. However, I'm going to say, no, that's not the case, because what we as installers don't seem to be getting a grip of, I think some people are, this technology is moving so fast. The effects on those copper cables is changing. The effects on the protection in the board is changing. The equipment we're plugging in is acting and behaving in different ways, and we need to adapt. And I see surge protection devices a internal protection measure for all of this weird fanciful stuff that we're installing, plus external measures. What are your guys' thoughts on it? Other than Kirsty, we don't need your thoughts.
Well, I go back to our common phrase, do the work. And if you're a competent engineer, spark designer, and you do the work, you'll see how technology has evolved. You'll see how protective systems have always mapped and evolved with them, and it's a no-brainer.
I think it is.
Yeah, I'll just add there that it's very easy to just keep doing the same old things because that's the way it's always been done. But of course, that doesn't work because stuff changes all the time. And if you just keep doing the old ways are best, of course, that doesn't fit in with what you actually need now. So while it's just tempting to say, oh, yeah, we didn't need this before and we didn't need that before. Yeah. Well, that may be the case, but things have changed a lot. So you do need surge protection now, and you do need other things like some of the other stuff we were talking about earlier. So think about what you're actually installing, rather than just saying, oh, well, because for the last 40 years we've done this, we're going to just carry on doing it in the same way.
This stems to a couple of things that we've covered now, and we've talked about this before with us, unwanted tripping of RCDs, device selection. Designers, when you look at the way BS 7671 is structured, or even things like the 2396 course, we must start getting an understanding of the equipment selected at the design stage, so we can actually have those characteristics and have that data to then carefully and correctly select a system.
But Dave, this is one of the big challenges, and I think this is where people kick back. Years ago, Sparks were designing for a certain load, and they were doing a fit out of a building. Let's say it's a Cat A fit out for some offices. Now those electricians are expected to understand what's being connected in, so they can configure the circuit division for a maximum level of leakage so that they're compliant. Otherwise, they're to blame. So there's a lot of cultural shifts in the industry.
There is, and the only way they can carry on doing that today is if they go for the worst case. And the worst case now, obviously, is considering SPD in every scenario, considering earth leakage protection of up to 9 milliamp, which means if you look at the regs, RCDs from near enough every socket outlet.
Yes.
Pretty much.
Yeah. You're looking at an RCBO board with the default board nowadays, and I recommend this should be RCBOs in every way, Type A in every way, and surge protection. That's your basic default board. But if you're still doing the splitters,
with the unwanted tripping, the ring final or socket outlet circuits of more than half a dozen sockets, could easily push over 9 milliamps.
No. And that's what scares. That is what's scary, because if you look at some of these standards that give you the information on the earth leakage from systems, I mean, I was measuring my house yesterday, and I've got 9.5 milliamps leaking from my house with just a TV and a few lights on. Literally 4 lamps and a TV, and I'm getting 9.5 milliamps leaking from that. So if you guys do have clamp meters, I know Mega do the DCM 305, cracking little meter for measuring what earth leakage in your house is. I'm sure, John, have you done a video on that yet? Earth leakage?
No, I haven't. But I did a domestic one the other day for some unrelated work. But it was an older dual RCD board, 10-way, sort of 5 and 5. Yeah. And the leakage on that, when it was running, was somewhere between 15 and 20 milliamps across the whole lot. And the customer said, "Oh yeah, the RCD trips occasionally." Well, it's like, well, it's not surprising, is it? Because I didn't do the split between which one was which, but up to 20 milliamps on a dual RCD board. So even if you were generous and said that was half each, that's 10 milliamps per RCD straight away, just for the fact of all the appliances that were connected. So yeah, it's quite an eye opener if you actually get a clamp meter and just check a few installations that you go to and see what's actually going on.
So my biggest I have a bit of a fear with this. That is a lot of electricians who, I know they're trying to avoid the race to the bottom in installing the split load boards, is you could end up installing a board and within 5 to 10 years it's being coded on an EICR, and that person is getting a report that could potentially, by someone nefarious, be unsatisfactory, and that will damage your reputation long term if you want a long term customer base. I'm just throwing that out there. Lastly, how to choose an SPD. Types, different types of RCDs, different part numbers, different model numbers. That has been a confusing one. I have to say that I have stood on a railway station and literally used my phone to find the correct device. I now have a catalogue, by the way, which I believe, Kirsty, you have at all your Alex events. A nice simple one. There are different types of devices. You need to ensure you select the correct type, and when you're doing that, you need to ensure the device is suitable for the earthing system. Kirsty, is that an important thing on surge protection?
Very important. Not so much when you go into commercial industry. Generally, there'll be a TNCS supply. But when you're working, especially in domestic, where you quite frequently get TT earthing systems, you have to be quite careful what device you select. If the device isn't suitable for a TT earth system, it can cause quite a lot of damage on the system when you get a surge, which is something they've actually picked up for the coding. So it's one of the very few times you actually will get a fail on an EICR if you have a TNS device and a TT board.
This was actually the question I was going to ask, because I understand the theory, obviously, with TT systems that the energy may not dissipate as rapidly with the TNCS system. I can picture the connection difference between position of the RCD, but what is the actual key criteria of the internal components of the device itself that allows it to operate still in a TT system if it has that higher impedance?
So it's a gas discharge tube or a spark gap. That essentially forms a barrier between the earth and the live systems. So if the voltage goes down and doesn't dissipate fast enough, essentially it can't come back up on the board. If there's no gap there and it's just an MOV, the MOV can work in a reverse way and we can get voltage back onto the board, which can cause more problems than if the surge device hadn't been there in the first place.
And that's exactly why we must select the right type of device for that earthing system.
Exactly. This is why quite often I have issues with the ones that are built directly into consumer units because they don't provide that sort of information. And especially with anything that's, like we said before, with the selection of the right type of device, they don't tell you that if it's if it's got an overhead line, you need a type 1. So the ones that are built in are actually no good. It's that lack of education, I guess. The contractor's just thinking, oh, I need a surge device, buying a board, it's got a surge device in it, and not considering the after effects of that.
Yeah, they kind of think of it as a simple like bolt-on feature instead of actually having correct selection to considerations. That's cool.
Yeah, one of my biggest concerns actually is my lads, when they're doing installation of these devices, that they understand the rules for the distances and all the rest of it, and that they're doing it properly, rather than, oh, I can only fit it there. If I need to move boards, I'll move boards. If I need to reconfigure my mains, I'll reconfigure my mains. I want to get it right. It's really interesting though talking about this, because we've mentioned BSEN 62305, which under regulation 1102, exclusions from scope, lightning protection is excluded from the scope of BS 7671, which probably does get backs of people up. But my favourite regulation, and I'm not going to read this out in my Liam Neeson voice because there's lots of you watching or listening. Sorry, yeah. So I'm not going to read it out. But one of my regulations, fundamental principles, 1316.2, and this hasn't changed since the last edition, and it says persons and livestock shall be protected against injury, and property shall be protected against damage as a consequence of overvoltage, such as those originating from atmospheric events or from switching, in accordance with the section 443, which nobody reads, and everyone thinks is a new edition, but that's been in the regs. It's been there a while. So there you go. I'm not doing that Emily Neeson voice, but I'll do it in another one where we're going to do a podcast, John, called Paul Reads the Regs in the voice of Liam Neeson. So stay tuned for that one. I need a lot of beer for that. So there you go. It's in the regs. It's always been in there. So back onto this. Is it suitable for the earthing system? Yes, because there are different types for different earthing installations. It's very important you get the right one. Another one, is the device providing protection for both the live and the neutral poles? Very important. That I believe all of surge protection devices protect on both poles, the ones that you manufacture.
They do, yeah. You should always be protecting against your live and your neutral. Unfortunately, some product manufacturers that don't necessarily understand surge protection very well, in the race to get the single module unit, have basically halved a double pole device rather than
they've compromised it. Yeah,
exactly.
Yeah,
sounds like AFDDs.
It sounds like AFDDs, Paul.
It sounds like FDDs,
Okay.
but some don't bother looking for series arcs on the neutral. Okay. I think one of the other interesting things that, because obviously we're coming towards the end of this, the surge protection devices that your company manufactures and sells, they're easily identifiable because they're bright yellow. As are you occasionally.
Yeah, I like to stay in theme.
Indeed. So if you're ever at an Alex, Kirsty will always be wearing a bright yellow, flying the flag. There are other devices. I believe, John, you pulled apart one the other day from some Chinese manufacturer, which was orange, which has cheered me up nothing rotten, because the device that I got that came on my main switch was orange. So now I have zero confidence in it. Thanks a lot, pal.
Yeah, those ones were just cheapo ones that came direct from China, mainly so I could tear them apart.
So I am now going to send you my one so that you can tear that apart and replace it with a surge protection device one, a nice yellow one. One of the benefits as well, I like, as we know from the modules, the replaceable modules, I think are a massive added benefit. I think they're a safer way of working. On railways, we have to shut entire stations down to change our devices, which is just insane. So I'm a big fan of the withdrawable modules. I think that's a good thing. The last thing I want to talk about is the warranties. So there was a question, and again, I think like with most devices, different manufacturers offer different warranties. Kirsty, what does surge protection devices offer as far as a warranty goes?
We offer a 10-year, full 10-year no quibble warranty on our devices.
Blimey. Okay, so what if there's an act of God and he throws lots of thunder and lightning? Let's say John Ward nearly takes out the grid, and everybody around him invests in surge protection, but he just keeps injecting loads of energy, and they blow. Would you honour those warranties because of someone like John Ward playing with electricity next door?
Completely, because I'm pretty sure the police had shut him down before he caused too much damage.
He would. It's all right. He keeps moving. That's just a set behind him. So you need to have confidence in the technical ability of your manufacturer. That's a given. And also traceability. I think that's one thing that we as E5 have been doing more and more and more, flying around Europe, asking for data sheets. I think for you, if you're a one-man band or a manufacturer, if you're installing a device, you need to have a level of confidence. For me, surge protection, I've had some bad experiences as of late. John knows what I'm talking about. So do you, Kirsty. I think you can guarantee the device, the unit itself, from failure. But I think we've got to remember it is a sacrificial device as well. If it's blasted with high voltage constantly, it will wear away and it will fade, because that's what it's designed to do.
It'll do its job. So
it will do its job, indeed.
So status indication is important.
Indeed. But
a question I get asked quite frequently, actually, on buildings that lose their neutral, for instance, a temporary overvoltage, which is completely ridiculous because you use pretty much the same symbols, because you have transient overvoltage and a temporary overvoltage. The difference, obviously, a temporary overvoltage is generally when you've lost your neutral, and it's like a continuous surge. So yes, a surge device will work, but it will burn out because it's not designed for continuous use.
Mm-hmm.
So there's a good point. If somebody does have a loss of pen conductor, that could be the issue. So I remember many years ago when I was learning, one of the things you were taught when you worked in houses was to get to know your area, not your area engineer as far as NIC, but your DNO engineers. Because if you were going into a lot of houses where there was the old lead sheath, pilk wrapped cables, you did get to know them, because if you needed a new earth connecting back on, you would build a. I mean, I did. I knew all the guys who worked out of Romford and Upminster and all the UK Power Networks guys, and you built a rapport and you got a trust of them. So, and they would also tell you what was wrong with the network, and you knew where to go and find that information. I don't think that knowledge is imparted to electricians anymore. I don't know. I've been out of the learning loop for long. What do you think, John? They probably got a warrant out for your arrest, actually.
Yeah, probably. But, yeah, there's. I think now the trouble is if you contact the DNO, and it's that if people that don't know it, the number's 105. If you just call that from anywhere, you get through to them. But of course now it will go to some central sort of call center type thing, and you end up with someone on the phone who may or may not know, and then they just send out whoever. So, I think
but that's the whoever.
You
need to get the whoever and find out who the regional manager is, and see if you can get in touch with him and just say, "Hi, look, I'm a local trading spark. I'm doing loads of work in this area. I want to help you, and I want you to help me help you, if that makes sense." And I found that worked wonders, because if the DNO guys think there's some good sparks out there who will help them in early spotting, and rather than them having to go out on a Friday night away from their family, they tend to be really courteous and nice and friendly and helpful, and help sort you out with bits and bobs and connections and stuff like that when you're under a bit of pressure. So worthy bit of advice. I'm going to kind of wind this up now, so I'm going to go around the room. Any other thoughts, comments, advice, feelings? John, start with you.
Yeah, I mean, I do mostly domestic stuff, and I'd say that in terms of the sort of risk assessment and all that other stuff, it's not particularly relevant. All I'd say is that if you're going to put a new board in a domestic, you may as well just price for putting the surge protection in it as standard. It's not a huge extra amount of money in the scheme of putting a new board in, so just price it up. If the customer complains about it, we'll say, well, you can explain it to them and why. So I think it's certainly in that context, it's not worth even just arguing whether you're going to have it or not. Just put it as part of the price and just be done with it.
And also tell them the benefits of it. It's protecting their phones, their Xboxes, their TVs. You wouldn't think twice, but when it goes wrong, it would be a terrible thing. Dave, final thoughts, mate.
I'll keep it short. My main real bugbear with this is, as we've covered in this podcast, the lack of understanding of the actual phenomena itself for electricians to effectively see when it can be a danger, or what kind of equipment, or to determine what kind of equipment can be exposed to this danger. This would be a lot easier if we could enhance that learning at much earlier part of an electrician's training. So we've covered the subject of the wiring regulations being biased to thermal. There needs to be a lot of work to just help not mention these theories or these subjects, but actually dive into them now, because these technologies are going to be taking ownership of our direction, of our training as we go into the future, and we've got to switch things around. So training's got to dive into this.
Maybe there could be a radical thing with the wiring regulations where they could maybe change it so they've got one that solely deals with the thermal issues, one with the magnetic issues, and maybe we could shake stuff up a bit. I don't know what the answer is. I don't know whether the JPEL committees do. I think they spend a lot of their time arguing and debating.
Well, we've still got this,
arguing a bit more.
We've still got this stupidity with is it AM7?
Yes.
Yeah, DC networks, DC currents, and AC networks. Yeah. So it's just something that just sort it out.
Well, I'm going to write a book, and I'm going to call it DC Breaker, I think, or something catchy. I don't know where I got that name from. I'll call it. No, but we could write our own book on it, to be honest with you. But there's a lot of research needs to be done.
So personally, that's my bugbear. Training needs to push electricians to a deeper understanding on this phenomena, so they can think for themselves. Moving on for that, I do think everyone should try and get to the Alexis to actually then go sit down and speak to Kirsty and everyone else at Surge and listen and just get some CPD on this. Ask questions. Look at everyone else trying to get an understanding on this. And pushing forward, we haven't talked much in this podcast about we've mentioned briefly about the details or the criticality of the length of the connecting conductors and the different orientations and the volt drops and all this thing. It's hard to put into a podcast. It's better to see it. And John hasn't released it yet, but he's got an upcoming video in his series which goes through it really, really well. So by the time this is out, I don't know if it will be up, but do go and check out John Ward's playlist. Video 5 will cover a lot on the connecting conductors and different connecting arrangements. And we can't display it in the podcast, but he's done little drawings on that. I looked at it last night. you know, and it's very educational, and that's something that we haven't managed to really illustrate here. But it covers the importance of the limiting and the length, even something as simple as having the MC, you know, the SPD on the opposite side of the DB when your main switch is at this end and your conductor's going, you know, one way and backwards like that. Simple things like that. Look at these resources. Go to an Alex, sit in front of Kirsty, listen to what she's got to say. One of us will be there as well, probably being awkward or joining in.
You'll be there. You'll be there at Manchester, Dave.
I'm in Manchester. Yeah, we're all gonna help out. But yeah, check out John's playlist as well.
Indeed, I think this will probably a couple of weeks. John, how long until your video actually hits the worldwide?
It'll be out before this podcast is, so it'll be there.
Great, awesome. So yeah, check out John Ward video 5. It's very good. David Savory actually did a video where he installed a unit, and a comment made him go back and do a corrigendum video full of expletives, which I love him for, and it just shows though the learning journey we're all on, and that's a fantastic thing. I don't see any weakness in people showing openly, I struggle. I struggle learning. This is new thing. I'm getting old. I'm used to my ways. The technology is changing, and the trouble is with electricity, especially the electromagnetic side of it, is that's the trouble with electricity. You can't kind of see it. You don't really want to touch it. You can't smell it. You can't hear it unless something's going seriously wrong, and it's something you can only try and control with copper and insulation. You know, we're cavemen in the application of electricity with, you know, you wrap it around 2 layers of insulation and tell it to go here. But now we've got all these funky electronics and mini computers manipulating it and playing games of it. And we still look at it in the ways we've looked at it for 100 odd years. And I think to absolutely paraphrase Dave, we as an industry need to level up. I think the manufacturers are playing a part, and Kirsty, thank you very much, because I think you are playing a part doing your talks at the Alexis, and I think it's fair to say you're always available to speak to anybody at all. You've been a great help to me for my railways way, giving me some great advice. But more importantly, we as individuals need to do the work. If you're looking for the quick and short, easy solution, do the work. Understand the knowledge yourself. John's done a cracking piece of work. I think, Kirsty, your presentations at Alex are good because they stimulate the brain cells. And Kirsty, I'm going to leave you for the final thought. Anything you would like to add? Question, query?
Really, it's just following on from what Dave just said. I mean, in terms of, there is no silly questions. I think especially with seasoned electricians, they very much think, oh, I'm not getting involved with that because they're worried they're going to look stupid or they don't understand something. They want to look like they know everything.
Yep.
Never be afraid to ask the question. I mean, my phone is literally always on. I'm pretty much always attached to it. Or send me an email or give me a call. I have got no issue in the world going through anything with anybody about surge protection. I don't care if you're not using my devices. I would much rather have you have an understanding on surge protection and be able to apply it properly. So we have safer installations. And I think if the whole electrical industry worked that way and it wasn't so much like money orientated, it was more towards training, then we'd be in a lot safer society, essentially.
Yeah, I don't disagree at all. I don't think any of the lads would. I think we need to do more to ensure the safety of the fixed installations, given the fact that technology is changing. I know many people, Dave and John, when we've shown them that little DC rig, they've been absolutely blown away. And trying to explain resonance and how DC can saturate or blind an RCD it's something that's going to take years, but it's an exciting journey to be honest with you. It really is. I think it is anyway. Same with surge protection. I think it's an exciting journey. Art fault is the exact same. It's great to be in a time of transition. It's a pain in the arse for us over a certain age. The youngsters will pick it up a hell of a lot quicker than us. The smart home installers will just probably do it by default because they're just walking encyclopedic computers. But yeah, I hopefully this is of use to you guys who have listened to our ramblings and the bits we've had to edit out. Anything else to say, gang? Right. Okay. Well, I'm going to end this now. Kirsty, thank you very much. Kirsty is available, by the way, from 5 a.m. in the morning till 1:30. Her number will be on the bottom of the YouTube. Please feel free to ring her at the most inappropriate times. No, I'm only joking. Kirsty, thank you very much. It's been cracking to do this with you. It's absolutely. Thank you for inviting us onto your panel talks at Alex. It's been a great laugh, to be perfectly frank.
And thank you for being not the first manufacturer to come onto here.
Yeah. and we challenge other manufacturers to come on and just talk and be grilled if we need to grill you, you know, and just tell us your thoughts and feelings, because it's fairly evident, Kirsty, having known you for a while now, you're incredibly passionate about this technology. It's not just your business, it's your passion, which is a wonderful thing, because that makes you kind of stand head and shoulders above others who just see it as marketing. So thank you very much. And on that bombshell, I'm going to end this the way I usually end this. This has been a bit of a long one. So until the next time, take care of yourself and each other. Bye-bye.
Bye-bye.
Bye.